A glass of ice water. Pretty simple, huh? But a lot of people believe it does something strange, that it turns your fat in your stomach solid and slows your digestion down. It actually sounds believable. We've all seen what happens when hot bacon grease cools. One moment it's liquid, a few minutes later it's solid. So maybe the same thing happens inside your stomach. But does it? Is your digestive system really that fragile? I'm Chrxstos, I'm a medicinal chemist, and let's follow that first sip and see what actually happens inside your body. Because the truth is a lot more interesting than the myth. This entire idea depends on one simple picture. Cold water reaches your warm stomach, and the fats from your last meal instantly harden into an indigestible lump. If that picture were true, the myth would make perfect sense. Fortunately, we don't have to guess. We can simply follow what happens inside the body. Our journey begins with a simple sip of water close to freezing. It passes through your mouth and down your throat before entering the esophagus. And here's the first surprise. The esophagus isn't just a passive pipe. It's a muscular tube that actively pushes every sip towards your stomach. And interestingly, this is the first place where scientists noticed that temperature can have a measurable effect. So what happens when that first wave of cold reaches the esophagus? Researchers have actually measured it. They looked at the wave-like muscle contractions that move every sip toward your stomach. This movement is called peristalsis. And yes, they found something. A very cold drink can briefly make those contractions a little weaker. That sounds important, but does it actually stop the sip? No. Even the muscular ring at the bottom of the esophagus may briefly change how strongly it contracts, but the water still passes through. For a healthy person, these changes are small, temporary, and don't interfere with normal swallowing. Your sip still reaches the stomach exactly where it was going. Think of it as a tiny hesitation, not a malfunction, and by the time you could even notice it, the water is already in your stomach. This is where the myth meets its bigger test. If cold water really stops digestion, this is where it should happen. Your sip enters a muscular organ sitting at about 98.6 degrees Fahrenheit or 37 degrees Celsius. It's surrounded by warm tissue and supplied continuously with blood, exchanging heat with the rest of your body. So what happens when something close to freezing suddenly arrives? Researchers have measured that too. The stomach doesn't stay cold for long, not even close. The amount of cold water is simply too small compared with the body's thermal mass. It's a little like dropping a single ice cube into a hot bath. The ice changes temperature far faster than the bath does. The same thing happens here. Within minutes, the water has already warmed dramatically, moving rapidly toward body temperature. And that brings us back to the original claim. Could the fats from your meal really turn into a solid lump? Not under these conditions. Your stomach isn't a bowl sitting on a kitchen counter. It's constantly mixing its content. It's continuously receiving heat from the surrounding tissues. And digestion never stops while that's happening. So the water warms quickly, but that heat has to come from somewhere. Does warming it costs your body meaningful energy? It does cost energy. That's simply thermodynamics. The surprise is how little. The energy cost is so small that in everyday life it has essentially no practical significance. But the effect is tiny. It's now here near large enough to matter for meaningful weight loss. So the popular image of cold water freezing the fats in your stomach doesn't survive what actually happens inside your body. So the fat doesn't freeze. But could cold water slow digestion in a different way? To answer that, our sip needs to leave the stomach. It can't all leave at once. Instead, the stomach releases its contents gradually into the small intestine. Think of it as a carefully controlled gate. So here's the obvious question. Does cold water make that gate stay closed a little longer? Researchers have tried to answer exactly that. And this is where the story becomes a little more interesting. Some studies, particularly older ones, did report a small delay. Cold liquids sometimes remain in the stomach for a few extra minutes, but other studies using different methods and conditions found little or no meaningful difference. So what do we do with that? We resist the temptation to pretend the evidence is cleaner than this. At the moment it's mixed. There may be a small temporary effect under some conditions, or there may be no meaningful effects at all. Either way, the scale matters. Even we assume the studies showing a delay are correct, we're talking about minutes, not hours. Imagine a 2-minute delay on a cross-country flight. The departure is slightly later. The destination doesn't change. Digestion is much the same. For a healthy adult, there is no convincing evidence that this short delay meaningfully affects digestion or nutrient absorption. So, does the mean temperature never matters? Not quite. Everything we talked about so far applies to healthy adults, but biology is rarely one size fits all. Some people experience sensations in their digestive system much more intensely than others. One example is irritable bowel syndrome, IBS. For some people with IBS, even stimuli that most of us barely notice, including temperature changes, may trigger symptoms such as discomfort, cramping, or pain. Doctors call this visceral hypersensitivity. It's simply responding more strongly to the same stimulus. There are also rarer conditions. One of them is achalasia, where esophagus having difficulty moving food toward the stomach. In these individuals, studies have shown that cold drinks can worsen symptoms, while warm drinks may provide relief. So when someone with a diagnosed digestive condition consistently experiences symptoms after cold drinks, that response can fit a known psychological mechanism. That doesn't make cold water harmful for everyone. The important point is this: there are exceptions. They don't change what happens in a healthy digestive system. The same glass of water can feel very different depending on the body drinking it. But for the healthy body we've been following, the journey is now almost over. So what happened to our sip of ice water? Exactly what your body designed to handle. It entered as a sudden thermal disturbance, and within minutes the body has absorbed that disturbance and carried on. We often imagine digestion as something fragile, something that can be thrown off by a cold drink or a small change in temperature. But that's not what the evidence shows. Your digestive system is remarkably stable. It's constantly mixing, regulating, adjusting, and adapting. Of course, there are exceptions. Some medical conditions can make temperature matter, but for a healthy adult, a glass of cold water is simply another input that the body handles with a remarkable efficiency. And maybe that's the bigger perspective. If this changed the way you look at a simple glass of water, that's exactly what this channel is about. We uncover the chemistry hiding inside everyday life. If that sounds like your kind of curiosity, I'd love to have you here. Thanks for watching. I'll see you on the next one.